بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, in this lecture I'm going to show you how to solve the programming output exercise of the final exams. So we'll start by spring 2018, and here we have some interfaces and classes defined. Okay, and then below you will have questions for different instructions, and you have to show the output of the instructions. So the most important thing is that you first read carefully the different classes and interfaces available for you. So we have an interface image. It has two methods. We have an abstract class image IMPL that implements the interface image. It has attributes here. It has a constructor. Okay, and the constructor prints something. Okay, it prints image created. And then we have an abstract method show, get height to string method. We have gray image extends image IMPL. We have also RGB image and image processing. So different classes. Okay, so here you need to write the output produced by the statement in the row just below. If the statement causes an error, and the error can be compilation or runtime, so you have to make difference between both. Sometimes you have a compilation, it means the compiler is going to detect that, you cannot execute. And in some cases, مثلا downcasting or whatever, the error is going to be discovered during runtime, so you need to differentiate between both. Fill in the row below with the compilation error runtime to indicate this and explain why the error happens. So you must indicate if the error is compilation or runtime, not just error. You have to tell why. What kind of error and why it is compilation or runtime error. And you must propose a solution for the error. For each statement, the response must be fully correct or will be counted as completely wrong. Partial answers are not accepted. Any invert response will be counted 0. Okay, so let's start by this one. Okay, image 1 equal a new image IMPL. What is the output here? So we're going to go, first of all, we will see the interface image and image IMPL. So image IMPL implements image. So in terms of polymorphism, it's okay. Okay, you have general class and subclass. Okay, so what will be the output now? What will be the output? Huh? It's going to write image created. No, this is not correct. Why it's not correct? Look now. New image IMPL, and image IMPL here is abstract. Is it possible to create an object from an abstract method? No. Okay, so here we have compilation error. The compiler is not going to allow this because the method or the class image IMPL is abstract, and we cannot create objects from abstract methods. So a solution will be to use subclasses of image IMPL to create objects. So here we can use concrete subclasses, not abstract. Is this clear? Okay, so the second one. Now we have here, we create a new image processing. We have to make it line by line. So I will go and check whether image processing has a constructor. Yes, it has. And here it's going just to write image processing. So I need to copy this part over here. Okay, and then it will create a new gray image. Okay, it will create a new gray image. So let's go to gray image class.
Just creating the image processing, not gray image.
No, the first instruction, it creates, it just displays image processing because this is the constructor. It displays that. Now I go to the second line. Okay, second line.
All right.
Yeah, we create a new gray image. So I'm going to go to the class gray image, this one. So I will use this constructor. And this constructor is going to do what? It's going to print gray image created. But before that, because gray image extends IMPL image. So usually it's like we have here. So in principle, you can write super. But super, because we have a default constructor, we cannot write it. But super is going to call what? The super class constructor. So that's why we will have image created first called, and then gray image created.
So what if the super class has two constructors? Which one does it choose?
It has two constructors.
Yes.
Yes. It depends on the parameters, the signature of the constructor. So here we have the constructor with default parameters, only one. That's why we don't need to write super, by the way. Okay? But if you have many constructors, super will depend on what argument you're going to put. So here we're going to make image created and then specify the width and the length. So 15 and 25.
Should it be the values of the class itself?
Sorry? 40, just a moment. No. Yeah. Not even 1525. It's going to put to 40, 20. Okay? Yes. Because these are the default values before making the assignment. 40, 20. And then we go to this constructor. After making the changes, okay, we're going to create now with the values. No, which one? With H and W. Yes. This one, not this constructor. It's the constructor here. Okay, with H and W. So I'm going to change the values and then write gray image created. Okay, gray image created 1525. So we will do the same for the next one. No need to do the steps. Okay, and here we will have 30 and 50. Is it clear? So pay attention when you have inheritance. The constructor of the superclass is going to be executed first before the constructor of the subclass. Okay, so if there is any print instruction inside the constructor of the superclass, you have to start writing it. Okay, a common error is just to forget writing these instructions. People just forget about that. Yes.
Can we go back to the subclass?
Yes. This subclass.
Okay. Where's the values of 14 and
No, they are here. They are here. So when we call the constructor of the superclass, the first value of height and width will be those by default. Okay. And then we will add the image. So we have to check, is this correct? So IPG is a generic class that takes gray images. So it's possible to store gray images. And here we have a first gray image, a second gray image. And here we do the casting because it was declared. If we don't do the casting, there's going to be compilation error because for the compiler it is declared as image. Okay, so these two instructions are going to be okay. Then I'm going to remove, it's not a problem. And then I will print the value of IPG. Yes?
If we don't cast it, when we run it, will it not run?
Mm-hmm.
If we don't cast it to gray image, will it still not run?
Yeah, it will not run. We will have one after that. Yes, if you don't cast here, it's going to be a compilation error.
But then we say, like,
It's
if
going.
we don't cast it ourselves, the compiler does it for us.
No. Because here you want to add an image inside a gray image object. Okay? And the compiler doesn't see this part. That's why we need to do the casting here. Okay, so the last line, we're going to print IPG. So I need to go the toString method of image processing, and it is just returning the size. Size images.size. Okay, so we're going to write size 1. That's all the thing. Okay? So you have to do it step by step. It's simple, 15 points plus 5 points of the recursion. In principle, you should be getting that quite easily. Okay, let's look at the third one. Let me know what will be the solution here. So first of all, we're going to have IPR. Here we have RGB image. In principle, we will have image processing. And then IPR.add new RGB image. Okay, so let's look at image processing first. Image processing, it takes any element that extend image, so RGB image is correct, and also is comparable image. Look now, for gray image, it was fine, comparable. But RGB image, it is not comparable. So here, we cannot even write the following. So the compiler is not going to accept even the first line. Why? Because this type is not comparable. And the generic type here, okay, look at this. It must be comparable. And RGB image just extends image ampere, and it's not comparable. In contrast to gray image, it was fine. It was comparable with no problems. You see the difference? Okay, so here what we will have? We will have compilation error because RGB image is not comparable. A solution to this is to implement the comparable interface to RGB image. Clear?
Professor, I'd just like to understand something. So the issue here is that RGB image, the class it extends from is not compatible, so that's why it doesn't work here?
Yes. It's not comparable. Look now, there is a condition on the generic type. It must be comparable. And RGB image, which is used here, it is not comparable. So it's going to be a compilation error. Okay, what about the next one? We have a set of image set. Equal new tree set image. Then we add gray image and then we add RGB image.
We must have the comparable, right?
Yes, same thing for the set. We must have comparable. However, the interface image is not comparable. Yeah, so compilation. Are you sure? No, here we have runtime. Yeah, here we have runtime. Okay, it's class cast exception. We're gonna have class cast exception because we did several times with tree set. We can put something not comparable, but it's going to be discovered during the execution. Okay. Class cast exception because image is not comparable. A solution to this will be to make the interface image as comparable.
So is there a reason why it's a runtime error, or is it just to change the settings?
Yeah, if you try to going to find it runtime here.
But what? Why is it not giving an error before?
In Java compiler, it doesn't give an error. We can try. We have tried this before. Okay. We have tried this before. Let me make an example.
Does this apply to all sets?
Yeah, for the other sets, yes. Where did we learn this? In Java Collection Framework. Yeah. So you can do. Let me make another one. Testing set. Okay. Public static void main string x. So we can make set of is person here comparable. Let's remove implement comparable here. Of person set equal a new tree set, and you have person. We need to import is it accepted? Okay. Now if you execute, no problem. But for example, if you make person set, because you know the compiler looks at this. Is there any error here? Is there any error? No. Okay. Now if you make tree set here, it's still accepted. Okay, but person set dot add new person.
So why does it still accept it when you do tree set?
Yeah, it doesn't. Let me check. Let me check with set first. So now we're going to have a class cast exception. Yeah, here it doesn't actually check the condition on this one. But if you do a generic class yourself, it will check. For example, if I do a class, my class, okay, مثلا, which is generic, T extends comparable on anything, string مثلا. So if we make here reset my class equal new reset my class. So this is fine. If I same thing, okay. It will only, for the set, it's going to discover only during the runtime.
So sir, the error comes when you do the dot add.
Yes, the dot add here.
Right.
Yes, same thing. Okay.
So is it the same?
Yes, now for example, if we make my class of type integer, in principle it should be discovered here. Okay. Look, now it didn't accept because integer is not comparable with with the string. Okay, so this is compilation. Okay, so what about 5? This instruction is going to be like the previous. Okay, so simple. And this instruction 5, we cast image IMPL to IM3 and then the show. First of all, is the casting possible?
No.
Are you sure?
Yes, it is. No, it's possible.
Yeah.
It's possible.
Okay, if it is possible, what's going to do? It's going to execute the show show of image IMPL. Okay, image IMPL. It has a show method, which is abstract.
So it's translation.
Okay. Okay, this is abstract. It's going. So we have two possibilities. Either is going to execute the show of this class. Great. Or is going to be compilation error.
Or is it going to cast itself back?
So first of all, the casting is possible because image 3 is declared as image. And image IMPL is an instance of image. So this is possible. Now, when it comes to executing the dot show, درسنا في البوليمورفيزم, is going to execute the method of the subclass, the rule. So what is the subclass here? It's gray image. Gray image, even it is a subclass of image IMPL. So it's going to execute the show method of gray image, which is the subclass. And this one is going to call the toString method, which will put gray image %s. So it's going to make a gray image %s. What is %s here? Yeah, it is super.toString. The super here is for the class image_impl. ToString is just the height and the width. Okay, so the height and the width will be, instead of this, we're going to have the height 15, 25. Okay, you must just trace it, you know. You have to do it step by step. Okay, so first of all, we agree that this casting is correct because image_impl is a subclass of image, and .show is going to execute the subclass version, which is this one, and when you go, this one will call toString method, which contains gray image, and calling super.toString is going to call the width and the height of the class. So the last one, we have a map. Image map equal a new hash map. First of all, the key here, we have hash map, so no problem. Then we make, is there any instruction to print here? First line? No, we just create a map, no instruction. Then we will put an entry into the map with the key im01, and here we create a new gray image by calling the default constructor. So of course we know that when we create a gray image, we're going to call the superclass constructor, and then gray image created. What is the default value? Default value here 50, 60. Okay, so we will put here 50 and 60. And then, so same thing, we have RGB image 1525. We will do the same thing. And here we have RGB image created. How much? 15, 25. And finally, print image map. So it's going to print the image map. And we have to know what is the structure of the map. Okay. So a map is printed by using curly brackets like this. And then we print the key and the value. The key and the value. So what is the key? The key im01. Okay, and then we put equal, and then we put the value is the toString method of the object. It's going to be the toString method of the object. So if we go to the toString method of the object, we will find gray image and then the width and the height. Like we did before. What is the width here? 50, 60. Then colon, the key im02 equal RGB image, and then the width and the height 15 and 25.
Shouldn't we take a line after the gray image?
Mm-hmm.
Shouldn't we take a line after gray image?
A line.
Yes. Because in the toString method of the gray image, it's has backslash at the end.
Where?
Gray image. toString.
Yes. Yeah, in principle we have to go to the line. It will do like this.
first 4 lines, we shouldn't write them because he only wants the output, right?
Yes, the output, because no, the first 4 lines is for new. When you call the constructor, this constructor is going to print the 2 first lines, and the second constructor is going to print these 2 lines. Okay, we can do a few more examples from. There is a similar one. No, there is 7. No, 6. Fall 2000. Is there anyone on images? No?